All right, so hi, hello everybody. A very happy Republic Day to everyone present over here. I welcome you all at the very amazing platform Unacademy. So we are here to ace our term to examinations with Unacademy Plus. Now, what is an Academy Plus and how are we going to, improve our performance by being a part here? I'll be telling you, but before that, let me tell you a bit about myself. So, I am Ritika, a chemistry educator on an academy. I have completed my engineering in electronics and communication, and I have been awarded grade A in Cambridge English USL. So today I am here bringing with me another amazing session at the YouTube channel of the only amazing platform that is Unacademy, right? Okay. Now, students, what are we going to study today? The students who are already, with me, they might be knowing that we have completed various equations, right? We have completed Boyle's equation, Charles' equation, etc. So we have been studying the gas laws lately, and today we are going to focus on the gas equation. Okay, so that becomes a very important chapter from your term to examinations, right? Now, students, there's a request that you can follow Unacademy Champions page on Telegram. So this page, the description box, it has got the link of the page. And why to follow it? Because at over here you will be getting the daily information of all the YouTube classes that we are going to have, of all the special classes, about all the ongoing offers and batches, etc. So that makes this page a very important one, and you should be following that. Also, subscribe us on YouTube. So let's target 1,000 subscribers, and that thing will be achieved only by your help. So you need to press on like button if you like this video, and you can share this video with your friends, and also you can subscribe to the channel by pressing bell icon so that you do not miss any amazing updates of the sessions going on here at Unacademy. So study of gas laws we will be starting, and we will be revising a bit first of all. Now, in our last classes, what did we study? We studied about Boyle's law and we studied about Charles' law, right? So let's start by a quick revision. Okay. So we studied about, first of all, Boyle's law. Now, what did Boyle's law state? So it stated that volume of any given mass of gas, it is inversely proportional to pressure. So volume of given mass of gas is inversely proportional to the pressure. Now, what is the thing that needs to be remembered over here? At a constant temperature. Now, here the temperature, it is maintained as constant. So, we do not have any change in the temperature. Okay. So, by this law, we get the equation as P1 V1 is equal to P2 V2, which is equal to constant. Okay. And this is known as Boyle's equation, right? Okay. After that, we learned about Charles' law, right? So let's see what is the statement given by Charles. Okay. So Charles' law stated, first of all, that if pressure is constant, like if we keep pressure constant, then what happens is the volume of given mass of dry gas, it increases or decreases by 1 upon 273 of volume at 0 degrees Celsius for each 1 degree increase or decrease in temperature. Now, Charles' law, it could also be explained by another statement. So the second statement could be given as volume of any given mass of dry gas, it is directly proportional to temperature. And here, what is the thing, or what is the quantity that remains constant? It is pressure. So pressure is equal to constant over here. So according to this equation, we can write V1 upon T1 is equal to V2 upon T2 is equal to K. Pressure being constant. So this is Charles' law equation. Hello Aditya. Okay, so I hope that is very much clear to you. Now let us move on to our today's learnings. Okay, so we will be first learning about absolute zero. Now from the Charles equation, we had V is equal to V naught 273 plus T upon 273, right? Now if I want to take out the volume at minus 273 degree centigrade, so what will be my volume equal to? So V naught into, now see, if I write or if I put the value of temperature as minus 273, so it will be like this, okay, and that will be equal to what? 0. Okay, now what we can say, that volume of gas would reduce to 0 at which temperature? Minus 273 degree centigrade. Okay, so what was said by Kelvin, Lord Kelvin? So if temperature of any enclosed gas at 0 degrees Celsius, if we are reducing, or if we are lowering the temperature to minus 273 degrees Celsius, the volume of that gas, it will become 0. Now this thing, it is not possible practically. Why? Because as you know that gas is one state of matter, right? So definitely the state of matter, it should have some kind of volume, some definite mass and volume is very necessary. Okay, so therefore this temperature minus 273 degrees Celsius, it is known as what? Absolute temperature. Okay, now all the gases, they either liquefy or solidify before reaching this temperature. Okay, if I talk about practically, this temperature, it is impossible to attain. Okay, and in theory, this is the lowest temperature that we can reach. Okay, that means all the molecular motion, okay, the molecules moving here and there, that should stop. Okay, but in reality, in practicality, this temperature, it is not possible to attain. Hope that is clear. Now talking about conversion of temperature. Now see, if I talk about conversion from Celsius to Kelvin. So the value in Celsius, it can be converted to Kelvin just by adding 273. Okay, so what do we need to do? We need to add 273. Now how is that possible? See, for example, I am having 0 degrees Celsius. So what I am going to do is 0 plus 273, which makes it 273 Kelvin. Similarly, if I have minus 273 degrees Celsius, so it is minus 273 plus 273, that will be equal to 0 Kelvin. Let's take the example of 20 degrees Celsius. So we have 20 plus 273, which makes it 293 Kelvin. Right? Okay. Now, if I go for just a minute. Yeah, so now if I go for, we learned about the conversion from, just a minute, yeah. So we learned about conversion from Celsius to Kelvin. And what was the equation? We just needed to add 273. Now, when we need to convert from Kelvin to Celsius, we simply need to subtract 273 from it, and we will be getting the temperature in degree Celsius. Okay. Now, students, this two equations are important whenever we go for numericals also, because it is very important to see what the units are present. Okay, see, if one temperature is given in Kelvin, other is given in Celsius, so we have to convert them both into one particular unit, right? Okay, now talking about the gas equation. Okay, so what does gas equation says? Let's see. Now, if we talk about both pressure and temperature of any fixed volume or a mass of gas, we change it, okay, then what will happen? The combination of Boyle's law and Charles' law, it will be giving a relation. Okay, so in the equation of Boyle's law, what was the condition? So according to Boyle's law, we were told that volume, it is inversely proportional to pressure. Okay, and according to Charles' law, we were told that volume, it is directly proportional to temperature. Okay, now if we combine these two laws, okay, the volume of any given mass of gas, it will be, so V is directly proportional to temperature and inversely proportional to pressure. Okay, now removing this proportionality sign, what do I get? I get V is equal to T upon P into constant. Okay, so in the place of constant, I can write V is equal to, first of all, V is equal to T upon P into constant, or if I shift it, we can write P into V upon T is equal to constant. Okay, now if I am having any gas which is having the pressure P1, okay, the volume is V1 and temperature is maintained at T1. Now it will be at, if it is changing the pressure, volume and temperature to P2, V2 and T2 respectively, then this is the equation that we get. So this is the gas equation. Now what is gas equation used for? So see, if things like, for example, if pressure and temperature both are changing, so how to calculate the volume? We use the gas equation for that. I hope that is very much clear. Now let's move on to standard temperature and pressure, that is STP. Okay, now volume of any given mass of gas, as you know, it changes regularly if we change the temperature and pressure. So therefore it becomes very necessary to select any particular kind of standard values of temperature or pressure to which we can refer to. Okay, now talking about the standard values, so the standard values which we have chosen, they are 0 degrees Celsius, and in Kelvin it is equal to 273 Kelvin. Okay, that is for temperature. And if I talk about pressure, so 1 atmospheric unit. So we also refer it as ATM, and that is equal to 760 millimeter of mercury for pressure. So these two values, that is 273 Kelvin and 760 mm of Hg, they are the standard temperature and pressure. So we call them as STP. Okay, so here we can write standard temperature it is equal to 0 degrees Celsius or 273 Kelvin, and standard pressure it is equal to 760 mm of Hg mercury or 76 centimeter of mercury or 1 atmosphere. So these are the standard values that we have. Now if there is any change in pressure or temperature, what will happen? The volume, it will be changing like accordingly. Okay, so it is very important to note down the temperature and pressure carefully, because if there's any change, the volume, it will be changed. Okay, now a very important information for all the students over here. So as you know, today is Republic Day. So Unacademy has an amazing offer for all of you. So students, on the occasion of Republic Day, Unacademy has got a very special thing for you. Now, if you are taking, or if you take the plus subscription of 1 year or above, okay, so this is the first condition, the subscription, it should be of 1 year or above, you will be getting the subscription of 6 months absolutely free. Okay, so you will be getting an extra 6-month extension for no cost. But here, this offer, it is applicable only from January 25th to January 27th. So now you only have 1 day left. Okay, and you can use this code, which is RLIC10, okay, for getting extra 10% discount. Okay, now students, it is very important for you to know why is plus subscription needed. So first of all, in the plus subscription, your whole course, it will be covered. Okay, you will be having extra doubt classes and answer writing sessions in addition to your normal classes. And in normal classes also, you can talk to your educators, you can discuss your doubts, you can have a one-on-one discussion in your classrooms, right? So it's very important for you to be a plus subscriber as for now, because your term 2 examinations are very soon going to start. Okay, and you need to take your preparations very seriously. Okay, so you will be getting the help of your educators, and you will be provided with all the study material, and you will be given all the special batches access, right? So please go for it, and especially if you go for the plus subscription right now, that is from January 25th to January 27th, you will be getting the subscription of 6 months. That is, this is the extension that you will be getting for zero cost. Okay, so please share this news with your friends also, and you also please try to avail this offer as quickly as possible. Now let's do some of the numericals which are important from your examination point of view. Okay, all right, so let us start. Okay, so your first question is, just a minute, yeah, let us start from here. A given mass of gas, it occupies 572 centimeter cube at 13 degrees Celsius and 725 millimeter of mercury pressure. What will be its volume at 24 degrees Celsius and 792 mm of Hg pressure? Now, first of all, if we get the numericals of this kind, it is very important to note what are the things which are given to us. So, if we look carefully, what are the things that are given? First of all, we have been given P1, that is 725 mm of Hg, right? After that, the volume, it is given to us in centimeter cube, that is V1 572 centimeter cube. And what is the temperature given? T1 is 13 degrees Celsius. Now we will be converting it into standard value. So for Celsius, we will be converting it to Kelvin. And from Celsius to Kelvin, we just need to add 273. So what the temperature is now in Kelvin? 286 Kelvin. So these are the three values. Okay, so P1, V1 and T1 is sorted. Now we will be going for P2, V2 or T2, whatever is given to us. Okay, now talking about pressure 2, that is given to us as 792 millimeter of Hg, right? If I go for V2, V2 is something that we have to find, right? It is unknown. And T2, it is given to us as 24 degrees Celsius. Now if I add 24 to 273, I will be getting the answer as 297 Kelvin. I hope everything is clear till now. So it's very important to note down the things whatever are given to us. Now, the gas equation, what does it say? P1 V1 upon T1 is equal to P2 V2 upon T2. Now what do we need to do? We just need to substitute the values. Okay, so P1, V1 and T1, what are the given? So P1 is 725 into 572. And what is T1? So T1, it is given to us as 286 Kelvin. It is equal to pressure 2 is given to us as 792 and V2 we have to find out, and temperature 2 it is given as 297. So on transferring, what we can write, V2 it will be equal to 725 into 572 into 297 upon 286 into 792. And if we solve this, we will be getting V2 as 543.75 centimeter cube. Okay, so this is the answer that we get. Let's quickly see what was given in the question and how did we pick out the answer. We were given a mass of gas at a particular temperature and pressure. So we took 725 mm, the pressure was given, the volume was 572, temperature 1 was 286 Kelvin that we converted from degree Celsius. Again, pressure 2 was given, temperature 2 was given, okay, and we had to pick out the volume. Now, how to pick out the volume? We will be going for gas equation, which says P1 V1 upon T1 is equal to P2 V2 upon T2. We substituted the values, we transferred the equation, and we got our volume 2 is equal to 543.75 centimeter cube. Right? So I hope that thing is very much clear to you. Now let's move on to second question. Alright. So second question says that gas is enclosed in a cylinder at STP condition. At what temperature does the volume of the enclosed gas become 1/6 of its initial volume, pressure remaining constant? Now here this question is very important. Okay, so first of all, it is just given that STP. Okay, no volume is given. So what we will do, we will assume. So let the initial volume be V1. Okay, so we are taking the initial volume as V1 because there is no value given to us in the place of V, right? Now, what is given in the question? Let us read it. At what temperature does volume of enclosed gas become 1/6 of its initial volume? So what will be our final volume? Let us take final volume as V2 and it will be equal to 1/6 of initial volume. Okay, we can write it as V1 upon 6. Okay. Alright, now talking about the conditions that are given to us. So we have been given STP conditions and we saw in the standard temperature and pressure, what do we have? We have temperature 1 is equal to standard is 273 Kelvin. Okay, now see student, what do we need to see in, or what do we need to notice in this particular question? We do not need any reference of pressure. Now see, pressure is given to us as constant. Okay, so there is no change in the pressure in the whole equation, right? Now what is the relation that gives the, what is the law that gives the relation between volume and temperature with pressure being constant? So it was Charles' law, right? So by Charles' law, what was the equation? We were told that V1 upon T1 is equal to V2 upon T2. Alright, now since pressure is constant, so we do not have to touch it. Now what is V1 given to us? We have just taken it V1 and temperature 1, it is 273. Now V2 is given 1/6 of initial volume, so that becomes V1 upon 6, and temperature 2, it is given what we have to find out. Okay, so this is the thing that we have to find out. Okay, now what we can write? We can write it as V1 upon 273 is equal to V1 upon 6 into T2, and if I transfer it, I will be getting T2 is equal to, just a minute, okay, just a minute students. Alright, so we were here. Okay, so if I take out the value of temperature 2 by transferring, I will be getting it as V1 into 273 upon 6 into V1. And if I take out the value of T2, it will be 45.5 Kelvin. Right? So this is the value in Kelvin that we have. Now, in our question, the temperature was asked. So, first of all, this is our answer. And if you want to go for the value in degrees Celsius, how do we get it? We will be subtracting this T is equal to 45.5 minus 273 for degrees Celsius. And the answer will be equal to minus 227.5 degrees Celsius. So, what's our answer? Either 45.5 Kelvin or minus 227.5 degree Celsius. Hope that is clear. Okay, moving on to our next question. Okay, so the next question says 26 gram of oxygen, it is enclosed in, in 1 dm cube flask at 25 degree Celsius. Okay, calculate the pressure exerted by gas if the molecular mass of any gas it occupies 22.4 liter at STP. Okay, now what is given to us? Okay, first of all it's 16, I'm sorry, 16 gram. Okay, so first of all, if I talk about oxygen, we write it as O2. Okay, that means it is what? A diatomic gas. Okay, so what will be the molar mass, that is molecular mass? It will be 16 into 2, that is 32 gram. Right? So I hope that is clear. Now, we have been told that the molecular mass of any gas, it occupies 22.4 liter at STP. So that means 32 gram of oxygen, it occupies how much? 22.4 dm cube at standard temperature and pressure. So what will 16 gram of oxygen occupy? Now it will be occupying how much? 22.4 upon 32 into 16. Now that will be equal to what? It will be equal to 11.2 dm cube. So now let's see what are the values that we have. We have first of all pressure 1, that is 1 atmosphere because it is given. Okay. Next is volume 1. So volume 1, it is given to us. We have just found out it is 11 point, just a minute. Yeah, it is 11.2 dm cube. And temperature 1, it is given as 273 Kelvin. Right? Okay. Next, what are the things given to us? We have to find the pressure, the volume. 2 is given as 1 dm cube and T2 is given to us as 273 plus 25, which is equal to 298. Right? Now we have got all the values and we have to take these values or put these values into the gas equation to see what is the answer. Now, we have T1 V1 upon T1 is equal to P2 V2 upon T2. Okay. Now, here what we can write as, what is the thing that is not given to us? P2. So, if I transfer what is P2, it will be equal to P1 V1 into T2, okay, upon T1 into V2. Now, if I put the values, what will be my answer as? So, P1 is here 1. What is volume 1? 11.2. And what is temperature? 298 because it is T2. Okay, it's 298. Next, T1, it is given to us as 273. And what is our V2, volume 2? It is 1. Now, if I take the answer, the pressure will be equal to 12.2 atmosphere. Okay, so that becomes my answer. Okay, I hope that is clear. Now, okay, I'm sorry students, there was a bit of network connectivity. Let's move on to our next question, that is question number 4. Okay, so hi Mohammad Uzair, hello, how are you? Now we will be having another question, that is question number 4, and let's see what does this question says. And this question is a bit important, okay, and it is a bit different also from all the questions that we did. Now we will be seeing what is the difference over here and how to solve the questions of this type. Okay, hello, hi. Now, 50 centimeter cube of hydrogen that is collected over water at 17 degrees Celsius and 750 mm of Hg pressure. Calculate the volume of dry gas, see, at STP. The water vapor pressure at 17 degrees Celsius is 14 mm of Hg. Now see students, what are the values given to us? Let's write them first so that there's no, there's not a lot of confusion. Now, first of all, we have been given volume 1 as 50 centimeter cube. Correct? Then we have been given temperature 1 as 17 degrees Celsius. Converting it into Kelvin, I have 17 plus 273, that makes it 290 Kelvin. And pressure, it is given to us as 750 mm of Hg. Now, is the thing till here, very clear? I hope that everything is clear till here now. Now, what is this thing given to us? Water vapor pressure. Now, the total pressure, it is, the addition of pressure of the gas plus pressure of water vapor. Okay. Now, this is the total pressure which is given to us, right? Okay. So, 750 is the total pressure and we have to take out the pressure of gas. So, pressure of gas, it will be equal to total pressure minus pressure of water vapor. Any confusion till here? I hope that everything is clear till here now. Acha. Now pressure of gas we have to calculate. Okay. What is the total pressure given to us? 750 mm. And what is the water vapor pressure? 14 mm. Right. So what we will be doing? We will be subtracting 750 and 14. So we will be getting an answer as 736 mm of Hg. Right? I hope things are clear till here now. Okay. Next, T2, it is standard temperature and pressure. So it will be equal to 273 Kelvin. And pressure 2, it will be equal to 760 mm of Hg. Now students, tell me, is there any confusion in temperature 2 and pressure 2? I hope that things are clear to you. Why is 14 subtracted? Okay, see Mohammed, see this question that is said that 700 mm Hg pressure is given to us, okay, and water vapor pressure is given to us as 14 mm of Hg. Now, the total pressure of any gas, it is equal to the pressure of the gas alone plus pressure of water vapor. Okay, now for this equation we have to get the pressure of gas, but we have been given total pressure. Okay, and how to get the pressure of gas? We will subtract total pressure from the water vapor pressure. Now what is our total pressure? 750, and what is water vapor pressure? 14. So that is why we subtracted 14 from 750. Is it okay? I hope that is clear. Now here we have 736 mm of Hg. So this is pressure of gas. Alright. And T2 and P2, they are standard values. Okay. Now if I put in the values in the gas equation. Okay. So P1, it is equal to 736 that we just now derived. Into what was volume 1? 50. And temperature 1 was 290 Kelvin. Ma'am, how can we say that which question is applicable in which law? Okay, so I'll be telling you, don't worry. Okay, yeah, next thing I will be covering this only. Okay, next is P2, which we have 760. Volume 2 we have to derive, find out, and temperature it is 273. So transferring all the values, we have 736 into 50 into 290 into 273 into 760. So if we take out the value, it will equal to 45.58 centimeter cube. Is this thing clear till here now? Okay. Next is question number 5. So the question says calculate the volume. Okay, so this is where we are going to clear your confusion. Okay. To calculate the volume of dry gas at STP, that is standard temperature and pressure, that occupies 28 centimeter cube at 14 degrees Celsius and 750 mm Hg pressure when saturated with water vapor. The water vapor pressure of water at 14 degrees Celsius, it is 12 mm of Hg. Now see, what are the things given here? Okay, first we will write that and then we will come to know which law should be applied. Okay. Now, first of all, what are the things given? Volume 1, it is given as 28 centimeter cube. Temperature, it is given as 14 degrees Celsius, which is equal to 14 plus 273, that makes it 287 Kelvin. Okay. Now pressure, it is given. Okay, so pressure, it is given to us as what? 750 mm of Hg. Okay, and this pressure, high crash, okay, this pressure, it is total pressure. Okay, and we have been given the vapor pressure as 12 mm of Hg. Now how to calculate the pressure of dry air? So pressure of gas is equal to total pressure minus pressure of water vapor. So that will be equal to what? It will be equal to what is the total pressure? 750 minus 12, and that makes it 738 mm of Hg. So that is our P1. I hope things are clear up till here. Okay. Next is we have to calculate it as STP. So at STP, what is our temperature? So T2 will be equal to 273 Kelvin and P2, it will be equal to 760 mm of Hg. Okay. Now putting in the values. Okay, now see Mohammed, what are the values given to us and how are we going to find which equation is suiting over here. So we have been given C, P1, that is 738, V1 and T1. So these three values are given and T2 is given and P2 is given. So we have to find V2, okay, and see, we are having a gas equation, right, which says P1 V1 upon T1 is equal to P2 V2 upon T2. Now there is this volume, okay, this value that we have to find and all the rest values are given. So here we will be applying our gas equation. Now let's see what are the values given. P1, it is 738. V1, it is given to us as 28. And temperature was 287. P2 is 760 into volume 2 we have to find out, and temperature is 273. Okay, so if I transfer 738 into 28 into 273 upon 287 into 760 is equal to V2. And if we find out the value V2, that is volume 2, it will be equal to 25.89 centimeter cube. Are things clear up to here? Is there any confusion, any problem? Okay, so I hope things are very much clear. Now let us move on to a bit of revision. Okay, but before that, let me tell you some of the important things of Unacademy subscription and why you should be subscribing to Unacademy. So first of all, students, you know that your term 2 examinations are very soon going to start, right? So it's very important that you take your preparations very seriously and you go for your preparations. Okay. Now Unacademy is providing the plus subscription, and this particular subscription, it has got some of the amazing features, right? So what are some of the features? Let me tell you. First of all, of course, you can learn from the comfort of your home. Okay. Now after that, you will be having unlimited access to all your courses. Okay, so whatever courses you have, subscribed for, you will be having the access of those courses, and you will be taught by top educators of India. Okay, next is, apart from your regular classes, you will be having the doubt clearing session and answer writing session. So what do we do in the doubt clearing session? We actually clear the doubts of all the students, and in the answer writing session, you are told that what are the answers, or what are the types of answer, and how you should be writing your answers. Okay, 25.86 centimeters. So see, it is 8 9. Okay, so it can vary a bit, right? That's okay, Mohammed. The correct answer is 25.8. If you round it up, you can even write like 25.9. Okay. Yes, Mohammed, I have taken your answer. Okay, so that is correct. Okay. Next is, your syllabus will be covered exhaustively, and you will be under the mentorship and guidance of your tutors, of your educators. You will be given all the PDF material, all the study material in the PDF format. Now, apart from these regular class, you also will be having practice test or live test, as we say. Okay, so you will get to know what are the things you are understanding, or what are the things that we need to work upon, and also you will be given the access to batch courses. Okay. Next is Unacademy Plus subscription for CISC board. So first of all, you can go for subscription of the plans. Okay, you can choose the duration. Okay, 6 month, 12 month, 24 month, whatever time duration you want to go for, just take it. And now students, you can see with every increasing duration, your per month cost, it will reduce, right? You can see it 1500, 1300, 1125. So this cost is going to reduce. So you can choose accordingly, and you can use my educator code, which is RITIKA CLIVE. So this is my educator code, which will be giving you a instant 10% discount. Okay. Now, as I told you that we are having regular batch sessions, so similarly we have one batch session. Okay, it is a crash course which is going to start from 7th of February. Now this is grade 10 and grade 9 course both. Okay, so ACERS, this is all subject batch. The delivery is in English. And students, if you are going to subscribe for grade 9, you will be getting the subscription of grade 10, 11 and 12 absolutely free. Now talking a little bit about the special class and what's so special about that. So we have Unacademy's free special class. Now these classes are absolutely free of cost, so anybody can watch it. Okay, here we have live real-time interaction, we have chats, emojis. Okay, you can participate in the quiz through polls. Now there are poll leaderboard option, which is a very amazing option. What is this? Is the educators, they ask you certain questions in your session, right? And you can participate in the polls, you can answer the questions, and you can also see the leaderboard. So in the leaderboard, it will be told that what are the answers that you have given, what are the correct answers, who has given answer quickly, who's the first, who's second, and all, right? So everything will be given to you on the leaderboard. Next special thing is that you can ask questions using question tab. So you can see a question tab over there. You can even attach the image. So you can attach image of your question, or you can type your question and ask to your educators. Now, how to watch my special class? So students, for watching my special class, first of all, you need to download the Unacademy Learner app. Okay. When you download it and install it, you will open it and click on Get Started. Now you will be entering your mobile number and your OTP. Okay. And you will be signing up using your email ID. You will be putting in all the information that is needed. Now in the you will be going for goal that you are preparing for. So in your case, your goal is class 6th to 12th. Select it and select your class and your board, CBSE, ICSE, which class, okay, and then language that you prefer to learn. That is, if you want to learn in English, select English. If you want to learn in Hindi, select Hindi. Or if you want to have a mixture of both, you can go for English. Okay. Next, in the description of this video, students, you will be having a link. Okay. So that is a special class link. Okay. And if you click on that, you will be having a pop-up of notify me. Okay. So please click on notify me. You will be notified just 10 minutes before the class is going to begin. Okay. And you can use my code, that is, okay, so this is my code which you can use to unlock the special class for free of cost. So students, please go and please see the special class. These are the really amazing sessions which, from which you can learn very much. Okay. So first of all, thank you, Mohammad Uzair. Thank you that you like the session. You can also share this with your friends and you can be regular because the classes are taken by various educators. Okay. Let's quickly revise what we learned today. Okay. So let's go back. Okay, so first of all, we learned about the conversion of temperature. From Celsius to Kelvin, we just add 273. From Kelvin to Celsius, we subtract 273. Next is the gas equation. So gas equation, it is a combination of Boyle's law and Charles' law. From Boyle's law, volume, it is inversely proportional to pressure at temperature constant. And according to Charles' law, volume, it is directly proportional to temperature at pressure constant. Okay, so when we combine both of these equations, we get PV upon the T is equal to constant, and this is how we derive the gas equation. Okay, then talking about standard temperature and pressure. So volume of any gas, it keeps changing with temperature and pressure, so we need to choose a standard value. So the standard values which are chosen are 0 degrees Celsius, which is equal to 273 Kelvin, and 1 atmospheric unit pressure, that is also equal to 760 millimeter of mercury for pressure. Okay, so these are the standard values, and then we did some of the numericals. So I hope that you understood the numericals very well, you understood the gas laws very well. Now in the next session, students, what are we going to do is, we are going to have some of the very important questions of this particular unit, the gas laws. Okay, some of the very confusing or important numericals and some of the questions. So please, try to attend the next session, as it is going to be very important from your examination point of view. And also please share the video with your friends so that everyone can take advantage of these amazing classes. So thank you. I hope you liked this session. We will be meeting in the next class. A very happy Republic Day. Keep studying, keep learning, and download the Unacademy Learner app.